Thank you, thank you everyone for attending. Let's give it one more minute before we start. Hello, my name is Yang, and I'll be your host for today's webinar on Manage and Secure Enterprise Multi-Cluster, Multi-Cloud Kubernetes Cluster with Loodse and NeuVector. We have a special guest today, Tobias Hense, Senior Engineer at Loodse, as well as our very own Dieter Reuter, Chief Solutions Architect at NeuVector. In today's webinar, Tobias and Dieter will team up to offer best practices for multi-cluster management for Kubernetes. They will also deliver and show how tools from Loodse and NeuVector can simplify the deployment and management of new clusters, workload, and security policies across the enterprise. If you have any questions, feel free to write them in the chat box as we go through the presentation. Towards the end, we will open up for Q&A. Tobias, would you like to take it from here?
Yes, thank you. So welcome all to our webinar. My name is Tobias. I'm a senior engineer at Loodse for almost 2 years now, and thank you for having me. I'm going to talk about the Loodse part, the Kubermatic product we have. And let's start with a little intro into Loodse as a company. So we are experts about containers and Kubernetes and cloud-native technologies in general. And we have a team of like 50 plus, or I think it's more like 60 plus leads. We are growing fast across Europe and also in the US. We actually founded and headquartered in Hamburg some years ago. And we are actually quite remote friendly. So we are spread really across Europe. So what do we do? What's our portfolio? So as I mentioned, we have our Kubermatic Kubernetes platform for orchestration, and supporting to this, we have like professional services. We have support on that. We do training for customers, which is just on container, let's say cloud native and all that, and also very specific workshops on the topic. One thing I want to mention next to our commercial product, Kubermatic, is also Kube One, which is a completely open source tool also for cluster management and creation, but just single cluster thing and command line driven. Let's open up with the interesting paradox. We found some statistics which say like 91% of companies in the field use hybrid and multi-cloud environments. And 72% cite the complexity of that as a major challenge, that hybrid and multi-cloud. But only 36% use orchestration for that, of which only 10% use automated orchestration. And that is really interesting because, I mean, we have 91% with a problem and only 10% attacking that with an automated solution. So let's talk about that. I start with one example here. There's yet another open source project of us called the machine controller, or the Kubermatic machine controller. You can find that at GitHub. And this is part of the Cluster API. Cluster API is a Kubernetes project, a sub-project of the SIG cluster lifecycle, and it takes care of declaratively and having a Kubernetes-style API in a declarative way for the things of a cluster creation, configuration, also management of your actual nodes. So it's sort of a meta level. And what a machine controller does, it introduces custom resources like machine and the machine set and the machine deployment, which gives you interesting things what you already know from deployments and replica sets and pods. We do the same thing with machines. So for one, we have with that CRD, we have the machine as a declarative object in Kubernetes. And you get things like rolling updates where you have the known strategies from the deployment. So you have zero downtime updates of all your nodes as well. Of course, with that and all the automation and that, you get self-healing capabilities of Kubernetes. If something falls down, Kubernetes makes sure to bring it back to the desired state. All this is automated, so no need to add nodes manually to your cluster. And as mentioned, that thing is open source. You have the GitHub URL there, machine controller. And this is used in Kubermatic, our product, and also Kube1, our open source project. And there was an interesting tweet flying around yesterday, which is pretty exact what machine control is. It's an operator which helps you to talk to the different APIs and bring more cluster nodes into your cluster. So we at Loodse, we see a transition here. It's up like a old world, new world comparison here on different layers. So on the infrastructure level, of course, you can go with the big cloud providers, Kubernetes solutions like EKS, GKE, AKS, and so on. But it wouldn't take long until you run really into a vendor lock-in. You go with some features which are really specific to these clouds, and you're locked in there. And we prefer to have the freedom of choice and continue to have that. From the developer experience perspective, the comparison of not being automated and being automated means like developers are waiting for operations, getting a new cluster for testing things, getting new nodes added to a cluster, compared to a self-service experience with Kubermatic as a platform. And on the operation side of things, it's the same thing. I mean, when humans are involved in the creation of clusters and adding machines and all that, it's resource intensive. It costs money, and we strive for getting that automated. When it comes to resilience, it's pretty clear. When you remove the human factor in the deployment that makes things automatic, you reduce mistakes. So that's heading toward highly available and self-healing infrastructure. And also talking about cost, when you automate things, you can save a lot of cost. You can pack things more dense with our solution and saving lots of costs here. Also, of course, when you need less resources in operations, that's another saving you have there. Less waiting times for developers, that's another saving. So what is this Kubermatic? So we call it a unified solution for automated cloud native operations. Our enterprise Kubernetes management platform. We run on virtually any infrastructure. We automate the operations. We help with getting density of your compute and also resilience by using Kubernetes for that. So basically, we run clusters within Kubernetes itself. So we're using the benefits of that. And this also helps a lot with security, implementing security and improving the developer experience in general. So how does that look like? We use the operator pattern a lot, and again, on different layers. So on the infrastructure layer, as mentioned with the machine controller, we automatically talk to different APIs like AWS, Azure, Google Cloud Platform as a big cloud providers, but also DigitalOcean, other smaller ones. But we also talk to APIs for on-premise solutions like OpenStack and VMware, vSphere for provisioning things there. Then on the cluster operation level, we are able with our solution to provision Kubernetes clusters and OpenShift clusters in different versions and in different locations at different cloud providers. And that's why we call that a multi-cloud and hybrid cloud control plane orchestrator. And we also want to go one step further when it comes to your workload. We are building tools to make it easy for you to actually have the same benefits from all the operation. And we're already providing monitoring and logging stacks, but we are helping you to create such sets and go in the same direction. So to summarize that, we add consistency from cloud to core to edge, meaning running in a public cloud or a private cloud, in a telco core, for example. This is running in telco cores already, and at edge locations with different kind of support for edge support here. And we are sort of making it uniform from a platform point of view, from the operations, what you do with the platform, for implementing policy and security. It gets uniform across different locations, cloud providers, and so on. And this helps again in management, and it improves the user experience a lot. We are proud to have one very nice user story here that's also in the handouts. This is a company, Sys11, and they are running a managed Kubernetes solution. So they're providing Kubernetes clusters to their customers. And before they decided on Kubermatic, they really had to scale the engineering. So they had to add a new engineer like every 10th customer or something, which was really a bottleneck for them, what didn't scale. And with Kubermatic, this got automated. So it's really a huge saving on their work. Let's do some demo. And to make this interesting, we are going into the command line as well a little bit, because I really want to show you the details here. So let's start with Kubermatic. So Kubermatic is a piece of software that's not as a service. It's a piece of software you get and it runs at your location. You see a login screen here, and we actually did not implement all the identity management identity providers on our own, but there are plenty of them already, and you have them as Active Directories or some other LDAP, or you have some OIDC providers. Like in this example here, I'm just using GitHub, and with that single sign-on, it's really like, yeah, I click how I want to authenticate, and then I'm logged in. Right, so what you see here, I created a demo project, and within that project, you see a colorful mix of different clusters I pre-created. You see them running here at AWS, Azure, some at Google Cloud, and also a OpenStack cluster running on OpenStack, which is actually running at Sys11, and also a vSphere installation in our Loodse headquarters in Hamburg. But I want to show you how we create a new cluster. So going through that by the user interface. So it all starts with a nice name, and after we select the name, we can decide, do we want to have a Kubernetes or an OpenShift cluster? And after the selection, we can go for a specific version of Kubernetes. That is configurable. You can decide what your customers, internal customers, external customers should use. So I'm going for that one because I want to do an update later as well. And one more interesting thing is you can add labels to a cluster. For example, let's add the demo label with the value live. And the interesting thing here is I'm going to create an AWS cluster, and these labels are actually going through to the actual infrastructure. So when we are creating nodes and all that, they will be tagged with these key value pairs, which is very important for cost management. Okay, we select our cloud provider. As said, I'm going with AWS, and they are also a region. I'm going with Frankfurt here. So then we have some settings to make, and that includes like the credentials for the cloud provider to be used. And sometimes it makes sense to allow internal customers in a self-service portal who just want to have a cluster to not give them actual access by giving them the credentials. So for that, we have custom presets, which is sort of a template of options. So the credentials are actually included here already. I can add, if I want to, I can add SSH public keys, which will be automatically deployed to the worker nodes. This makes sense for debugging things, logging in. It's optional, but I can do that. Then what I'm going to do is I'll add an initial machine deployment, a node deployment, and I'm going to add 3 replicas of that. So I'm going to go with 3 worker nodes. I can select the size of the instances that is fetched from AWS, the different instance types here. And let's go with a medium-sized something. And I could specify a specific AMI image if I want so, but we have built-in support for different operating systems here. So we have the Ubuntu, we have the CentOS or RHEL distribution, and our container Linux. So let's go with the container Linux, and let's continue. We get a summary screen with all the options shown, nothing special here. And now when I hit the create button, Kubermatic works very much like Kubernetes works itself. So it's very much aligned. So it's all loosely coupled, and we're using Kubernetes objects and CRDs for everything. And I want to show you how that looks like. So in my shell here, I have some kubeconfig files lying around. And one of those is special, and that is the cluster where my control planes are running in. So let's call it a master cluster. And I can go into that context here as well. And as I said, everything is a CRD. So I have the clusters as CRDs. And I can see the, not so colorful in the shell list of clusters I had pre-created. And when I now create that cluster here, and now get the list of the clusters, I have a new cluster, aged 4 seconds. And what's happening now is that lots of controllers run, and you get a new status update here with all the components of the control plane of your new user cluster. For example, the machine controller, very important, etcd for keeping state, and so on. And what's happening is all those controllers start doing their work, and one of those controllers is watching, oh, there's a new cluster. I need to create a namespace for that, because we put all those control plane components in a dedicated namespace. So let's have a look here. Let's go into the dedicated cluster namespace of our new cluster and see what pods we have. You see, we have like 30 seconds and almost everything is running. There's some readiness checks still due. You're still not completely ready yet, but in a few seconds it will be. In the meantime, let's have a look at another resource, at the cluster resource. So let's edit the specific cluster and have a look. It looks like a usual Kubernetes object. You have the kind, the metadata, you can have labels and all that. And some interesting things here, there are cloud provider references here so that you can see where it's running, different VPCs, all that, IP addresses. Another interesting thing is we have created attributes for component overrides. So if you say, I want to have like 3 replicas of the API server running, I want to have 1 controller manager, 2 controller managers, you can control that here. It's all specified there, the controllers read that and apply that. So it is ready now. The control plane elements are ready. So I can download a kubeconfig file. I have a kubeconfig file here. And I can go into the scope of my cluster. Let's see what we have. looks like an empty cluster, right? Let's have a look at the kube system namespace. That's always interesting. And there we can see that we have no pods yet because the machine controller just started the work. We have created machine objects. We can look at them. Machines, they are created. And the machine controller is now doing the work, talking to the AWS API. It obviously did that already because that's the external IPs at AWS already. And they exist like since 70 seconds. And now it will take a bit until the actual nodes will appear. So another interesting thing here is the machine deployment and a machine set. That's the other two important CRDs we have. And yeah, it's like with pods and deployments, right? Okay, so another thing I would like to show you while the nodes are getting ready. And when they are ready, they will register themselves with the cluster, do the bootstrap signing process, and register themselves as nodes in the cluster. But while we are waiting for that, let's go to another cluster here, which I had pre-created. This is how it looks when everything is ready. And let's go for a cluster which is not completely updated yet. For example, this one. You see quite an old version of Kubernetes here. And what we can do now is observe how the update works. So let's do that in our master cluster again. Find the cluster we have, the VMware one. It's this one here. Let's have a look at the cluster namespace of that one. And let's watch the pods there. Right, I created that 3 days ago, it seems, and API server and all that is running. And we are going to update that now to, let's say, the next version. And we also want to do the node updates, so updating the kubelets basically. So let's hit that one. What's going to happen is, you see, you get a new API server. It's really quick because we're using Kubernetes and it's just another manifest being deployed. We get a new API server version here, it's doing the rolling updates there, a new scheduler there, and some components that are new in that version are just getting updated. That usually takes like 20 or 30 seconds and the control plane is done. Really depends on the replica count of some of the components. And when that is done, what happens next is that the nodes are being updated. And there we are using our machine deployment. We are just changing automatically by the operator the machine deployment template, or the template in the machine deployment for the machines, and that updates just the version. And what's happening there is that we get a new machine set. Let's have a look here. Let's go to the VMware one. And in the kube system namespace, and let's have a look at the machine sets. You can see that we have two machine sets. That's the one we already had. We have a cluster with 5 nodes here, and we already have one new machine set. And in that machine set, one new machine is already coming up. And this is because our update strategy we have in the machine deployment says we can have at maximum one more than desired state. And if that one is ready and done, then one of the old ones is removed, then the next one is added, new one removed. And by doing that, you get the 0 downtime updates. That's the idea behind that. Okay, let's have a look back at our cluster we created. It should be ready now. Yes, it is. Like here, three nodes actually ready 5 minutes ago. So yeah, that was sort of the success I wanted to see here. And that's what concludes my demo. So I pass over to Dieter now after I go to our NeuVector thing, the integration here, because he has the credentials for having a look from NeuVector side on the clusters.
Okay, now I take over from Tobias, so thank you. So my name is Dieter Reuter from NeuVector, and here you see exactly the same logging screen. But before we dive into the live demo, let's go over container security first. So I would like to give you a short introduction what NeuVector is doing. So here's my presentation. Okay, so I'm working as a Chief Solutions Architect at NeuVector since more than 2 years right now. At NeuVector, we do, let's say, a lot of container and Kubernetes security. We do it in the full spectrum from development to deployment in the runtime. NeuVector was founded a couple of years ago in 2015. Headquarter is based in San Jose, California. I'm from Germany and head up that technical team here in EMEA. And let's talk a little bit about what we mean when we talk about lifetime container security. First is to mention security in the build phase. So whenever you build a new Docker image, scan it immediately for CVEs, having integration into your CI/CD pipeline, like Jenkins, like Bamboo, like CircleCI, GitLab, whatever, or Azure DevOps. Then the next thing is about you have these built container images. You store them in a registry. Can be a public registry like Docker Hub, can be a cloud registry or on-premise registry. So there is also the need of continuously scanning for vulnerabilities. And then if you go further into your live running Kubernetes cluster, you have several components where you have to look for security. First, let's say security like CIS benchmarks for Docker, for Kubernetes. On the runtime part, scanning for vulnerabilities in your platform, in your Kubernetes OpenShift system, scanning of your host operating system, and maybe also live scanning of all your running containers in production. Another thing where we focus pretty hardly, it's about analyzing the network traffic in your whole container cluster. So which means even east-west traffic between containers, between parts, automatically creating network policy rules, process policy rules, and then switching the cluster in a monitoring or in a protection mode, where you can even establish a full-featured layer 7 container firewall and all those stuff. So this is more in, I would say, a proactive and active protection of your container workload. And finally, all the security events which are generated in your cluster, we are able to collect and automatically send back to your SIEM system. Can be IBM Curator, can be Splunk. There you can, let's say, analyze them, taking immediate actions, sending an email, sending a Slack message, and so on. But I would say CVEs are not your real problem. CVEs are here, okay, these are vulnerabilities, but the more important thing is, more dangerous thing is the hacker itself. So there are studies in the US where they say more than 90% of all the hacking attempts are coming over the network. And that's exactly why we at NeuVector are focusing more in analyzing the internal network, trying to detect typical network threats, fulfilling network analyzing with deep package inspection, and automatically enforcing all network policy rules on the fly in your live cluster. And if you're looking into your cluster, into your container cluster, typically this is a blind spot. This is more a black box. And if you look into the network traffic of a small cluster, here's one of our customer Experian from the UK. And what you see here on the screen, you have some blue boxes which are representing pods and containers. Then you have all these lines, blue lines, red lines, which indicates the east-west traffic. These are the internal network traffic in your container cluster between all those parts. And typically currently this can't be inspected from the outside of the cluster. And all these, let's say, traditional network security guys using security tools which are sitting outside of a cluster, and these guys can't look into these traffic details at all, because all your traffic in a Kubernetes container cluster is, let's say, wrapped into an overlay network, encrypted, and it's really unlikely that these guys are having fun in trying to analyze it. So we are sitting in with our tools. We are sitting inside of the cluster, inside of each and every worker node, and we are able to inspect the network traffic directly. Here, for example, is a small short screenshot of our UI. So you see different containers. You see red lines, which means there is a blocked connection, or there were some let's say alerts on the network. And by the way, what we also can do, right-click on a pod and start a live packet capture of all the network flow into and out of this pod, then download it as a PCAP file, analyze this with your standard tools like DCB-Dump or Wireshark. And as I said, that we are able to inspect all the network traffic inside of your cluster live. The same thing we do even in a service mesh. In a service mesh, everybody says, hey, this is more a security tool, but what does this Istio really do is capturing your original application traffic inside of a pod with a sidecar, and then encrypts the traffic and sends the encrypted traffic over the wire. So the network connection between pods is now encrypted. But what happens if the hacker itself is already sitting inside of the application traffic? You have a vulnerability, and one guy was able to break in. You can't see these network attacks anymore, because right now it's obfuscated, it's encrypted by Istio. But with NeuVector technology, we are able to inspect the real traffic. We are able to showcase all the traffic, and we are able to enforce network rules and protect everything in this case. But now let's say go back to our original topic, multi-cluster. And here on the screen, I do have a screenshot where we add new clusters to our master cluster. We are able to sync, let's say, also global policies. But now I would like to stop with my theoretical part and switch back in a live demo. Hope this works. Okay, here we are back at our login screen. So log in as an admin. And here I'm right now, this is exactly my master cluster. And here what I have done, I'm able to head back to my multiple clusters. Here I have a list of all the connected clusters in this case. And right now, let's showcase a couple of my security features I have talked about. I just would like to switch over to this Loodse cluster. And if I look first at the nodes itself, you can see in this cluster, I have 3 nodes running, all 3 nodes running the latest Ubuntu version. And currently, we would like to make a live presentation, even if, let's say, assume you have a pretty high workload on your cluster. And you would like to have so 3 nodes are not enough anymore, and we have to horizontally scale our cluster up to 5 nodes. In this case, we just use Kubermatic to update the number of nodes. And in this case, I would like to give back the control to Tobias.
Okay, and here we go. So before we do that, that is the update I started. And as you can see here in the versions, we have almost 4 ready nodes. We have 3 ready nodes, and 1 is almost ready with a new version. and 2 machines are left. So it's taking some time, 1 machine at a step. So, yep. So the request was to scale up the GCP O2 cluster. We can see we have currently 3 nodes here. We can see that in the user interface here. And we can also see that here, if another watch running on that cluster, we have 3 nodes. And we have 3 machines, our representation of the machine controller. And one more thing, we can have a look at the machine deployment. Even here in YAML, we can see, yeah, 3 replicas it is. So I'm using the user interface right now. I'm hitting the edit button here and say I want to have 5, please. Let's observe what's happening. Immediately, you get 2 more machines. Now the machine controller is starting to get active. You can see the 2 here as well. And it got a name now, and now it's talking to the Google Cloud APIs and bringing up the machine. That will take a little bit. You can also have a look here and see, yay, it's 5 replicas now. So while we are waiting for the machines getting really ready, which takes 2-3 minutes perhaps, we switch back to Dieter and I'll let you know when it's really done.
Okay, so as Tobias said, it will take a couple of minutes. So this gives me the chance to introduce you some live security features which are already talked in my presentation. So first of all, what we do, it's more about we scan the platform for CVEs. So nothing is here in this cluster. I head over to nodes. We do a full compliance check. So here you find all the Docker CIS benchmark results, same as Kubernetes CIS benchmark results. Then we do have a tab for showing all the vulnerabilities we are able to detect on the different nodes. And here what we do is we are looking really into the host operating system, detect all the installed software packages, compare it to our CVE database, and show, let's say, everything what we are able to find. The next thing what we do for example, we do this same kind of CIS benchmark in live running containers. And also we are able to detect vulnerabilities in live running containers. But here, if you see, there are some system containers running, having some vulnerabilities. Here you see a column called fixed version, and this indicates clearly there are already fixes in place for these CVEs. So we just have to, let's say, if this would be an application container, send back a trigger, a message to your dev team. Hey, please update your container images, rebuild them, test them again, push it in the Docker registry and redeploy it. And please remove most of those CVE in the platform. So let's see if we have already the nodes. Nope, takes a little bit of time. And the next thing I would like to showcase how we inspect the network traffic. Here in this case, I have an empty cluster, only system containers. But what I can do, I can even inspect the whole network traffic between all my system containers. And if I click on one of those network lines, you can see we are able to inspect the network traffic, and with the help of deep package inspection, we are able to detect this is an HTTP protocol or a DNS protocol, and so on. And
you
even
should have the nodes now.
I should have the nodes now. Thank you for the report. So let's head back to the nodes, and here you can see we have the additional 5 nodes, and this reflects just how we installed, how we deployed NeuVector, because a couple of services, everything is deployed as pure containers, as a daemon set, and as soon as we have additional 2 nodes added into our cluster, Kubernetes kicks in, installs our enforcer pods. These are getting accepted by our cluster controller, and everything, all the basic rule set will get deployed on the new nodes as well. And in this case, then we have in our network activity all nodes available, all 5. And as soon as we, let's say, deploy a new application, a couple of new application containers, it will get fully protected from the first second on. And here you see even these red dots on the screen indicate, hey, we do have some vulnerabilities detected here in these containers. Okay, so that was more about how I use this and let's say switch back and forth between clusters. And right now, I just would like to add an additional cluster. And therefore, I have prepared another cluster. It's also deployed by Loodse. Here I do have my screen, and I go to administrator. I click on multiple clusters, and now I'm able to join an existing master cluster. And in order to do that, I just need a couple of things. First, I just let's say name that cluster, Google Loodse GCP 07. Now I need a token. This I'm able to take from my master cluster. I'll go to the master cluster, multiple clusters, get the token. So copy paste that thing. And the only thing and now you see inside of the token, I have my IP address, my port number, so my cluster can reach the master cluster. And for the other way around, I just need the IP address of my remote cluster. And in this case, I'm selecting my cluster. And now I need the IP address of my federation worker. This thing I can close. And as soon as I hit submit, my cluster joins the master cluster. So it says pretty much okay. Now I can take it away. And now if I say refresh, I should see my cluster 7 should appear. And right now I can switch directly from my single web UI to this newly added cluster 7. And if I look into the nodes, I see we have 3 nodes running, vulnerability testing is already activated, and so on and so on. And here you see it's pretty easy to do it on the UI. So, and now I can switch from one cluster to the other cluster. We also added, where it is, I just would like to showcase this live, federated policies, because this is the next interesting thing where you can define additional policies from admission controls, network rules, process rules, response rules. So we can define it on the master cluster, and then it gets, let's say, replicated to all of our attached clusters as well. So now back to the presentation. Okay, here I have some screenshots. So I added this, adding a new node, switching between nodes, and at the end, as a short recap, we have right now a single web UI where we can switch from cluster to cluster. It can be used for teams in DevOps, in security teams. We can define those federated policies. We can enforce all those rules across different clusters. And finally, I have to say this supports all typical cloud scenarios. So Kubernetes can be deployed in a cloud, can be also deployed on-premise, and with this multi-server, multi-cluster system, you can connect all those clusters together and handle it all the way. So I think now I'm at the end of my presentation of the live demo. and I think we can go back for Q&A.
All right, thank you, Tobias and Dieter. Let's open up for Q&A, so please write your questions in the chat box. Okay, so Tobias, first question is, with highly distributed clusters, also in different data centers or regions, how do you cope with increased latency to the control plane?
Yeah, right. So what I have shown and presented was sort of a simplified version where I talked about having one master cluster and all the control planes in there. And indeed, that would add quite some latency for talking from and to the worker nodes. But what we usually do, there's another feature where we can have more than one of those master clusters. We call them seed clusters, and we can put them actually in your data centers as well. So you can have any number of them. So if you have your Kubermatic running in your master cluster, and let's say you have a AWS data center, or you have stuff running in an AWS data center in Frankfurt, and you have something running in the US, then you would usually create a seed cluster in Frankfurt and a seed cluster in the US, so that when you create new clusters, you actually do that exactly there, so that you have your control plane with the namespace of your control plane components exactly in the same data center, so you have low latency. So that's how we do it.
Okay, and then do you claim to run on any infrastructure and support the big cloud providers? How does Kubernetes support running on less well-known infrastructures like smaller cloud providers, Tobias?
Yeah, so it's true. I mean, the support for talking to different APIs like AWS, Azure, and the big cloud providers, that is in machine controller. That's where it is implemented, because machine controller is what talks to the APIs and brings up new machines. And the thing is that it's very easy to add support there. So it's really just a Go interface to be implemented. And there's one really nice example for the support that was recently added for PacketNet, the bare metal hoster. And actually, the PacketNet people did that because, I mean, machine controller is open source. It's at GitHub. And they sent a PR for adding support for PacketNet. So all we had to do is add the icon of PacketNet to Kubermatic and integrate so accept the PR, integrate the new version of machine controller and that. So my point is, it is really, really easy to add support to anything that has an API that is good enough for adding new machines. So it's really easy, and it goes through the open source project machine controller.
Okay, and Tobias, is it possible to use other CNIs?
Yes, actually, the thing is, we try to deliver vanilla Kubernetes clusters. So we are we do not want to put any or a lot of opinion into that. So we have to add something. We have to add a CNI. We have to add some DNS and all that. And we have a mechanism for that, which we call add-on. We have a specific add-on image, which comes with Kubernetes, which is used, and everything that is in there is deployed to every new user cluster. And if you really want to have a different CNI, that is easy, because we provide means of having your own custom add-on image with your own custom list of add-ons. So you can remove the kernel, which is our default, the kernel CNI from there, and put in your own one. So no problem there. We have mechanisms for that. And for us, the CNI is just a workload. Yeah.
Okay. Dieter, in order to inspect the network traffic, are there any limitations of compatibility for specific CNI or network plugins?
Oh, thank you. Good question. So currently what we do, we inspect the network traffic directly inside of the Linux kernel. So this is way below. So from the layer below all these network plugins, all the CNIs. So in this case, we are fully compatible with Calico, with Flannel, with Weave, and all these other stuff. So okay. Totally no limitation currently.
Thank you. And then Tobias, does Kubermatic support vCloud Director?
We are working on it.
You guys are working on it? Okay.
Yeah.
And then Dieter, how is NeuVector priced?
Yeah, NeuVector is priced, let's say, on a worker node level for your productive system. And but for us, it's more important to get to know your use cases and how you would like to let's say implement your security infrastructure. And so please send us a call, send us an email, and we'll be really happy to help you out.
Okay, and then for that question, Tobias, how is Loodse Kubermatic priced?
It's similar. So of course, contact sales at Loodse.com, but in general, it's based on memory and CPU usage of the workers. So not the control plane thing, but the workers you manage, memory and CPU of that.
Okay, and then for either of you guys, is it possible to analyze network traffic between 2 or more Kubernetes clusters?
Yeah, sure.
Well,
so as I said, we analyze all the network traffic, not only inside of the cluster. So we also are able to analyze the traffic which comes in, so ingress and egress traffic. And if we have, let's say, an installation on both on 2 clusters, we can exactly see when inter-cluster traffic is happening. So yes.
Okay, and then Dieter, how is NeuVector installed on Kubernetes system? Do you need an agent on the host changing containers contents, or is it through using a sidecar?
Yeah, honestly, we have developed NeuVector in a cloud-native way. So we only deploy as pure containers. That's first to say. So as a Helm chart or as a pure YAML file, we don't need anything to be installed directly on the host like an agent. And especially, you don't have to change anything inside of your container. We don't inject any additional code, and especially we don't use any sidecar at all. So the only thing what we do is we are using all Kubernetes API features, Linux kernel features, so nothing special, and so just a couple of containers. So.
Yeah, and for the integration with Kubermatic, it's again our add-on mechanism where we can put the mentioned manifests and just add them to the list of add-ons, and they are automatically deployed to every cluster.
Yeah, and this means in Kubermatic, you just hit a single checkbox, which means, hey, please include NeuVector security by default, and then NeuVector gets deployed as at the time when you provision the cluster with Kubermatic.
Okay, and then Dieter, are you really able to intercept the network traffic even between pods, or do you use IP tables for segmenting the network traffic?
Okay, first of all, we don't use IP tables at all because IP tables it doesn't scale well, and we have customers which need to scale up to a couple of thousand of nodes. And what we do is we are really able to intercept all the traffic, and we do that with pure kernel technology. So we grab the IP traffic directly inside of the Linux kernel. We are able to analyze this, and this is extremely fast. And that's the same area where we are able to intercept the traffic and control. So we are able to, let's say, control, analyze the traffic between 2 pods. We intercept the traffic, and if we see there's a malicious content, a hacking attempt, we are also able to drop those packets. So it's, as I said, it's a real layer 7 container firewall.
Okay, and then can the multi-cluster handle on-premise and on-cloud, on-premise and public cloud clusters?
Yeah, absolutely, yes. And as you have seen how I was able to attach a new cluster to the master cluster. The only thing what we need is it's just an ingress to the cluster API. So only a single IP address and an endpoint, and then I can, let's say, I can have a control plane, a master cluster in the cloud, I have some remote clusters in different cloud providers, and for example, a couple of different clusters on-premise, and the on-premise clusters are able to just connect to the master cluster in the cloud.
Okay. And aside from federated roles, any way to push roles to each cluster in a more automated way?
Okay, thanks. That's a good question, because I didn't showcase that in my demo. But what we do, all the network policy rules, process file rules, they are attached to different groups and services. You can export them as a standard YAML file, and this is used as a custom resource definition. So you have that full rule definition on a file, you attach it to your typical Kubernetes deployment, check it into your Git repository, and as soon as you deploy that Kubernetes service to the next cluster, NeuVector kicks in, creates all the rules on the fly before the pod gets deployed.
Okay. All right, guys, we are hitting the top of the hour, so that would actually be our last question for today. If you guys have any additional questions, please write them in the chat box, and we will reach out to you personally to answer them. So great questions. If you would like a copy of the presentation, please send me a quick email at updates@neuvector.com or just to info@neuvector.com. Under handout, we've added the overview of NeuVector and Loodse for your reference. This webinar was recorded, so a follow-up email with the recording will be sent to you shortly after. Dieter, Tobias, great job. Thank you. And thank you everyone for attending. Great webinar.
Thank you for listening in.
Thanks,
Okay,
guys.
bye.